Okay, now we come, I would say, to something completely different. I have the honor to be the only representative of the automotive industry, and we are even an unknown company yet, so please allow me to introduce to you the Desay Automotive, which is a very fascinating company. It's a Chinese company, and it's almost the number one in terms of infotainment, and very much growing in the driver's assistance systems in the Chinese market. It is established in '86. It has undergone even a joint venture with Siemens VDO. So my Chinese colleagues have a kind of a European heritage also, which makes the business much more easy. It is extremely fast growing. This is normal for Chinese companies, but 23–24% each year over a long time is very fascinating. Yeah? And we have a lot of patents, like Rode and Schwarz. I have seen they have 300 more, so we are working hard. And all the other credentials, and as I said, infotainment, ADAS, and on the way towards autonomous driving, and that in the Chinese market, and number one market for automotive these days. Second, Europe. Third, United States. And then we come. We are a more than 100-year-old company, the so-called Antennentechnik Bad Blankenburg. And why do I mention it? Because we are here in East Germany, and we are just in the neighborhood in Thuringia. We are not in Saxony, but in Thuringia. And therefore, we are very much known for producing and developing antennas for trucks and for police cars. And everybody who knows how a police antenna looks like can act accordingly in the traffic and save some money. And we started with 130 employees this year, and we could manage to employ 50 people so far, and we will employ another 20 in the war of talents. This is very difficult. And what we do is, we have been acquired by Desay in China due to our antenna knowledge, and to create a hub in Europe, where we run all the projects of all the portfolio of the Chinese mother company, plus doing antennas. And all is, let's say, dedicated to do the most important antenna in the car industry, the so-called smart antenna that is closely interacting with the mobile network, with high precision GNSS, and that brings all the connectivity to the car. I come to that later. So we are really proud, I have to say. In times where Chinese companies are looked differently, we are very happy because they continue to invest and want to go with us in the European car industry. A few credentials, top 100 auto part supplier, number one in display system with an own display, manufacturing, vehicle infotainment number one. In driver assistance system, we have some market to catch up in China and global. And also for the domain controller, we are in a good position. Domain controllers are used for all this processing of images, of radar signals and so on, that will lead us to the autonomous driving in the different levels. So now you can say, of course I know Desay, and let's talk about connectivity. I did not bring a lot of slides because I like the way of doing the discussions here that we share today. And the connectivity in car industry has a short history actually. When I was at BMW, it started all with a small portal in the car where you can look into news and into weather. And then the next big thing, and this was about, I think, 2005, 2006. So, and it was, at this time we discussed heavily, can we afford to build in a SIM card facing all these costs, the low data rate, how will this evolve? Then marketing people said in 2 years there will be a ubiquitous network at low costs, and we can do internet radio, we can even switch off FM and DAB radio. So very extreme positions have been in discussions. And well, it went that direction for sure, yeah. And this allowed at least to implement the real-time traffic information, because I think these are two major use cases in the car is traffic information and being able to make phone calls. What else are you doing? Because you want to reach from A to B in the time that you have planned, and you plan every time a little bit shorter. Yeah? So this is let's say, the basic connectivity that you can see. And if you put all the fun stuff in, like internet radio, it was always a discussion. Do you put it on your smartphone as an app and you connect? Or I think I left it here at the table. Or do we put it in the car system? So this is an ongoing debate, and the trend, I think, is these days to go more into the smartphone if it comes to entertainment. And only the really car and driving related issues will be implemented in the car itself. So this lives close to each other, and it's an ongoing discussion that we have. And you can see on that list that the next thing will definitely be dedicated to driving assistance in any kind. And we say the North Star of connectivity is number 7. Yeah? Full autonomous driving level 5. And my experts, not my experts, the experts of our headquarters, they clearly say there will be no full autonomous driving without a connection to a mobile data network that does some processing and brings some information. It is not really 100% clear what that could be. Yeah? They talk about continuous updates of high definition maps. Of course, we will have a vehicle-to-infrastructure and vehicle-to-vehicle network, disregarding what standard it is, yeah? But this needs to be installed. And we need data beyond the viewing area, generally speaking, of the car. And of course, telematics is a very important point that is also used today. Your dealership knows if your car has a problem before it's recognized by yourself. Artificial intelligence will be key for automotive suppliers like we are, and also for car manufacturers, to really generate senseful data out of the continuous data that is produced in a car. I unfortunately could not manage to really count the data, but if you take all video signals, if you take all the data, you easily come up to maybe 1 gigabit per second. Yeah? The question is if it makes sense to take all the video signals into account, because it's also for the car very important that it assesses and that it is processing the images and then draws a conclusion out of it and then brings it into the data stream. I come to that later. But also the so-called brain to vehicle, which I like, and this is not a head here and that you steer the car without your hands. It is all about predicting traffic situations earlier than humans can do. And this also requires a close interaction with a network that collects all the data along the street. So I think there is a lot of business for 5G, but there is not one question asked who will pay for that, but I also would like to come to that later. So the car tries to be, and this is very important, and Tesla is, I think, quite well developed, to be as autonomous as possible. Yeah? And therefore, there are many technologies that you put in the car. Cameras, ultrasonic, short and medium radar, long range radar, LiDAR. And there are even religious discussions if you can do only with camera, only with radar, and so on. I think a hybrid approach is the only chance to do it. And then there's also an off-board part, which I was referring to. And then we need to check what data needs to be shared between those two systems. The local system of the car, looking as far ahead as possible, and the global system, or the roadside system, where the car is currently driving. And this is a discussion that is not ended yet, and needs to be further discussed. But we are all very clear that we have then to decide if it's real data traffic requirement, which would be really a challenge, or if, let's say, a package data but regular data stream would be enough. No? Discussion is also not ended. But the real-time mobile communication network at a low latency then will only be used by the car industry, and it would be an interesting question how we could set up this ecosystem. We had made, when I was at Kathrein until 2015, with another big tier one, really on one afternoon, kind of a calculation that it would need 50 to 100 euros per car to only equip the highways in Germany with an own network. Of course, it would be not economic. But at least if we have special requirements from the car industry, who pays for that 50 or 100 euro per car? And this is a rough estimate. Don't cite me here, yeah, but it's not for 10 euros. And then we talk not about Europe. And this is also very dedicated to countries that have own car production. What are countries doing that have no car production? So this is a difficult question. But let's come to something more beautiful, to antennas. We are on the wireless day today. And let's do a little bit technology. The antenna system and architecture is very clear. That is today on the car. It's a so-called smart antenna. What is smart about this antenna? You have a very integrated and condensed package where the antenna is directly mounted on the transceiver of the 5G module, also the GNSS module, and so on. Why do we do this? This is very easy. And this is, first of all, it is price-driven. If you save the antenna cables, you save a lot. You save minimum, if you look at such an architecture, 10 euros or even more of antenna cables and connectors. And secondly, the frequency are increasing, and beyond 2 or 3 gigahertz, and the typical length of a cable in the car of at least 4 up to 8 meters, you will not have a good signal at the end. So it's also physical driven. And this was pushing this smart antenna in the BMW labs. Now I can unveil it since 2010 even, when in my old times. And and then now it is an industry standard. And the interesting thing is that the value add really has left the antenna business from 2005 to 2015. All antennas were just some wires, some PCBs, and now the value add comes back to the antenna because software, electronics, and the antenna is one element. And this is a factor of 10 value add on a car versus a distributed classical system. And this is what we are going for. And I like that, of course. There are actually 2 integration options. The beautiful shark fin. If somebody is interested tonight on the steamboat, I can explain how the shark fin was invented. And it was invented by the BMW. And I had just the duty to make it bigger and bigger because there are more and more antennas coming in. Today we have 4x4 MIMO for high band or 2x2 MIMO for the low band mobile communication. Or you hide the antenna, and this is a cycle because sometimes the designer are winning and sometimes the commercials are winning. Yeah? And so you have different options. It's all very chassis driven, and therefore it's a lot of engineering work to make this all happen with different materials. And the most economic, and also from the antenna performance, is and will always be the shark fin that's looking ahead of the rooftop. But now we come to something boring. If you then really ask what the challenge in car connectivity is, and you talk with the big guys of car manufacturers, they all will tell you it's the heat. Because the antenna is very exposed to the outer and below the rooftop, and the semiconductor industry stopped 20 degrees below with its standards that what is needed there. So unfortunately, the ecosystem today is really small because the semiconductors are not here, but we need definitely to take care for a successful rollout of the car connectivity also in the future about semiconductors that are much more, that can cope with much more heat than today. There are beginning families now, the semiconductors, and then we come to the cost question. And so this is the story. It's something trivial maybe in your minds, but this could also slow down the ecosystem here in the car connectivity. But this is my favorite one, because the speaker before was talking about ecosystem, and I would like to bring to your attention how the ecosystem in the car industry is. and I really made some rough estimations, yeah, really rough. We have a $6 billion smart antenna market volume in, I think, in 2025. I forgot to put that number in, starting with a 14% CAGR from 2018. Out of the $6 billion, more than $4 billion are required for us as a tier 1 supplier for materials, for components. And you can guess that the semiconductor industry, with the latest and greatest 5G and later 6G chips, in brackets, which get really hot under the rooftop, earn the most of it, about 70%. It's a typical cost structure. And there is somebody who is not and never on any conference. These are the licensee guys. Yeah? Please forgive me, I do not want to suppress R&D, and I know this also needs to be financed. But the magnitude in the meantime of 15 to up to 20% of an electronic control unit of a car is dedicated to 5G licenses and some other licenses. This gets critical because maybe not now, but when we all work on 6G, maybe it's 30%. I have no idea. But therefore, I would bring to that really small but eloquent audience this message. And what is the value at the production? It's another $500,000, so $0.7 billion plus or minus stays with us, the tier 1s, to cover overhead and profit. And it's almost the same magnitude that is eaten up by licenses. And if we now talk about who will finance a very dedicated network, not a single network, but maybe part of the network, a network slice for the automotive industry, when it comes to autonomous driving, this looks quite different. But I can tell you, if you think, okay, the car industry is paying for that, I know who is paying for that. That is, again, the supplier landscape. So the only appeal I have here at the end of my presentation is we should take care that we don't overdo the license story, and we need to look at the entire ecosystem also for the car industry. I know it's not always the most attractive one. It's easier to get a hell of a number of people with their mobile phones and earn the money from that. On the other side, it is a huge and disruptive innovation if we go towards autonomous driving, but we also need to finance that story. And let's say we need to take care of that story, let's say between 2035 up to 2040, when it goes to my Chinese colleagues. I just had a short chat this morning, but don't get me on 5 years precision. I think when we have clarified the finance, the legal guys will kill everything. So there is so much work to do, but the connectivity could be ready. And I heard from your Huawei colleague, the architecture of the network is already developed since years. So the car industry needs to develop the system, but then we also need to talk about something like that. But I would like to end with 2 slides to give an outlook what we are doing to be able to serve the connectivity story for autonomous driving. This is China on the left. This is the second plant. We have a multi-scenario test site for autonomous driving in China. I don't have it yet in Weimar, where our European headquarters is located, but let's see. And we also have acquired a new company for roadside infrastructure. So for us, it is also a kind of a duty not only to think on the car, but also to think on the infrastructure and to have an end-to-end competence built up. And this is what we do in the beautiful city of Weimar. And I'm really looking forward to such a campus network. Yeah, I just learned 1 hour before I gave that speech that this could be even deployed in an industrial area to make some testing and so on. So this is a takeaway for me in that conference. And we will invest another 20 million in modern measurement facilities for connectivity in cars, not on an antenna diagram basis, on data throughput, and on functional basis. So this is what we do, and I'm happy to receive your questions. Thank you very much.
Dr. Weber, thank you very much. Before I check out if there are questions from the audience, I will have to ask one, because if there's an opportunity to learn something for our private lives, we have to jump on it. What does a police car antenna look like? What do we have to look out for?
Okay. Okay, most police, if the police car is a premium car, normally you don't have nothing on the rooftop or you have a shark fin. But if, let's say, a Mercedes, an Audi, or a BMW shows a mast antenna, then it's not a regular car. Okay. And the likelihood is high that it is a camouflage police car. Unfortunately, we also master the ability to integrate the police antenna in the shark's fin. So I gave you a tip, but don't rely on it to 100%.
Okay. Still, you might stop working on that. Okay.
I should do it, yeah. I travel a lot.
So thanks for clearing that up. Are there any more questions to Dr. Weber? I'll bring you the microphone, just a moment.
Thanks. I had a question on the smartness of the antenna. You
Yes.
said it's the cables are removed and it's part of the TCU. Is there any kind of adaptivity on these antennas to tune to multiple frequency bands, or also to tune to future frequency bands, or is it still kind of fixed radiation pattern and you need to design the antenna to fit certain frequency bands, and then you go for this for the lifetime of the product?
Well, I think each NID or TCU is dealing with several bands because this is the standard of mobile communication. If you mean beam steering, then I can only say partly yes, because we have MIMO antennas. That means more than one antenna for the mobile communication. That is, let's say, improving the signal and also the data channel and then the throughput. And smart for me means that the antenna has no coaxial connectivity, but an Ethernet connector. And all what you was asking for in that direction is processed directly on that main board that I have shown to you. So it is a TCU with antennas, or antennas with TCU and with a data network connection. Pleasure.
Thank you very much, Dr. Weber.